We're given a question where it's a velocity time question based on the diagram that we're seeing, where we've seen velocity being mapped against time. It says that a motorist travels from rest. So here will be where rest would be, right here. Travels from rest. It travels 30 meters per second as a speed for the first 5 seconds. Alright. It then says that it maintains speed and then it decelerates for the next 7. So it maintains speed for 10 seconds and then decelerates for the next 7. Alright, so we're looking to calculate some things based off this now. We're asked to calculate the acceleration in the first 5 seconds. What is the acceleration in the first 5 seconds? So we know that acceleration is basically the gradient. What would be the gradient of this line? And that's what we're really looking to find. So in order to use the gradient formula, we need to know 2 points on the line. So we need to know where it starts. So it starts here and it will end there. Alright, so it starts at the point 0, 0. And it will end at the point, based on here, it will end at the point 5, 30. Remember that we read from x-axis to y-axis. So it starts, the x value would be 5 and the y value would be 30. So find a gradient using those 2 points. So the acceleration is basically what's this now? Let's go. This is x1, y1, x2, y2. These are 2 points that are plotted. So it's y2 minus y1, that's the formula for gradient. Y2 minus y1, that's 30 minus 0 over 5 minus 0. And this is will be now meters per second squared. Alright. So acceleration basically is 30 over 5. 30 minus 0 is 30. 5 minus 0 is 5 meters per second squared. And we know 5 into 30, we're going to get 6 meters per second squared. So that is the acceleration for the first 5 seconds. We're also asked to calculate, based on the graph, we're also asked to calculate what is the what's the speed at which the car decelerated. Yes, the motor is decelerated. So the speed at which the motor is decelerated, will come from this line. This shows the deceleration. So it's going from 30 all the way back down to 0. Alright, so it shows when you apply the brakes, this shows the deceleration here. So deceleration is the same thing. We're finding the gradient of the line. So I'm going to be using the 2 points on the line same way. So I'm going to be using this point now. This point, let's read out the coordinate. So it's 15, 30. 15, 30, that's 1 point. And next point to be here. Now we know that all points on the x-axis would have a y value of 0. So we know that this is 22 to 0, 22, 0. So we do the same thing. So in doing the same thing, calculating the gradient. So this is x1, y1, x2, y2. So this would give us y2 minus y1, so that's 0 minus 30 over 22 minus 15. So the acceleration would actually be negative 30 over 7 meters per second. And because of deceleration, yes, you'll find that you'll get this value to be negative. So we can work out this value here. We can work out that to be a decimal if we choose, or we can leave it as is. Alright, now we're also asked to find the distance traveled. Now the distance traveled is always the area of the graph. It's the area of the polygon that is being formed. So the polygon that's formed here is a trapezium. So how do I find the area of a trapezium? Area of a trapezium will be half of the sum of the parallel sides multiplied by the perpendicular height. So we'll call the parallel sides, because we know that these are the parallel sides, we're going to call up here A and down here B. So all of down here is B and all of here is A. So all of this distance is A, all of this distance is B. We know that the height would be the value on the y-axis, so that we know that that is 30. So here we go. So say area is equal to half of, what's the distance of A? From 5 seconds to 15 seconds, that's 10. So that's a gap of 10 seconds. So it's half of 10 plus total distance here will be 22 multiplied by the vertical height, and we know that the vertical height is 30, and that will be 30 meters. So working this part out now, we know that this is half of 32 multiplied by 30, and that will be 16. We know half of 30 is 16 times 30 meters. So the area would be 480 meters. So we know that this now, that would be the distance traveled. So anytime they ask us to calculate the distance traveled, find the area of the graph that is here. Alright? Now the last part of this question would be asking us to find the average speed. What was the average speed throughout the entire journey? What was the average speed throughout the entire journey? We know that average speed is equal to distance traveled over time taken. Right? So we know that we know the distance. Alright, that would be the distance. What was the time? Now the time, now remember that the time was from from no second here to the 22nd second. That's on our way, but yes, to the 22nd second. So to be 22 seconds. And when we divide that as a mixed number, we will get 21 and 9/11 meters per second, and that will be the average speed of the journey, and that's how we would work out that question. So again, acceleration, we find the gradient of the line that is here, we find the gradient of this line that is here, here, find the gradient of that line in the first 5 seconds. And now to find the gradient, I take the 2 points on the line, and find the gradient of it. So I took the 2 points, found the gradient. And I did the same thing for the deceleration there. Take the 2 points that are there, find the gradient. To find the area, we know that we'll find the area. To find the distance traveled, we'll find the area of the polygon that we have here. And once we know the distance traveled, we divide it by the time taken to find the average speed for the entire journey. And that is basically velocity time graph.